class. This is part 6 of this tutorial video, and we are going to be looking at we are going to continue from where we stopped in our previous tutorial class, right? Now we'll be looking at question number 4, question number 5, and question number 6 under complex sort, under multiplication and division of sorts, guys. Of course, I know you have gained much values before now, but let's add more values to what you have gotten from us. Now, God helping us, we have this on the board. We are asked to simplify this. Like I explained before, we have so many number of ways you can simplify this, but I just want us to solve these problems in a way that will be calculator independent, right? Yes, it will be calculator independent, will not depend on calculator at any point. All right. Now, we are asked to simplify or evaluate 500, the square root of 500 times 48 all over root of 125. All we just need to do here, guys, is a matter of choice to say 500 times this. Since they are both inside square root, you can multiply them and you have an answer. Then you can find the square root of the number if possible. But like I said, I prefer that we split them. We reduce each of these sorts to their least form before we can apply this multiplication and division signs that we have in. If that is taken now, let's get started by reducing 500 to its least short form, reducing 48 to its least short form, and also reducing 125 to its least short form. Now, for 500, as usual, we know that this would have given us 100 times 5 will give us 500, for which 100 is a perfect square, right? Then times 48, I think we have done 48 before, yes, and 48 is 16 times 3 without that. I'm just trying to use the values because I don't want us to waste much time. Then all over 125 would have given us 25 times 5. Hope this is clear. Now the next thing we do is that the square root of 100 is 10 times root 5, then times, which is this multiplication side, then the square root of 16 is 4, multiplied by the square root of 3, which is root 3, all over the square root of 25 is 5 times the square root of 5 is root 5. Now the next thing we quickly do is to multiply out the numbers, or you can simply say this goes into this, and this would have given us 2 because 10 is divisible by 5. So automatically we are going to now have 4 times this 2 times 4 is what we have as the whole number at the numerator, then times root 5 times root 3 all over root 5. Also, we know that root 5 can take care of root 5. We would have even cancel that here. Okay, now having done that, also root 5 can also take care of root 5. Root 5 divided by root 5 is 1. So at the numerator, we are going to have 2 times 1 times 4 times root 3. While at the denominator, we just have 1 times 1. Now, 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8. And 8 times 3 times root 3. 8 times root 3 is 8 root 3 over 1. And this is 8 root 3. This is the answer to this very question. So, 10 is divisible by 5. We divided 10 by 5 and we had 2. Root 5 can cancel out root 5. That was how that cancelled out. Then what we were left with is 2, 1, 4, root 3. That's what we have here at the numerator. And at the denominator, this is 1, 1. 1 times 1 is 1. And anything divided by 1 is the same thing. So this is what we have. Now let's look at the question number 5 very, very quickly. Now in question number 5, we are asked to simplify 2 root 14 times 3. Yes. Now we want to look at question number what? 5. In question number 5, we have 2 root 14 times 3 root 21 all over 7 root 24 times 2 root 98. As usual, you can always multiply out 98. Now, as usual, you can always multiply out, like I said, but we don't want to multiply. We want to reduce each of these. Of course, 14, the factor of 14 is 7 and 2. There is no perfect square. Then the factor of this is 7 and 3. But now we know that we have 7 here. We also have 7 here, right? This partner is not a perfect square. That's why I said there are multiple ways of solving this. I want to use this method now, so I will therefore have this as 2 roots. What is 7? This will have given us 7 times 2. Although none of them is a perfect square, but the product of this and this, I'm going to find a perfect square there because I have 7 here. I will also have 7 here, and 7 times 7 is 49, and 49 is a perfect square, and that's why I want to do it that way. So you have the option of doing it in your own way, but provided that you are not manipulating values. Yes, you heard me right. You must not manipulate values, but once you know you are applying rules, mathematical rules, don't hesitate. Go ahead. So I am confident in using this method. I'm sure I'm going to have the answer because I know the rule I'm going to use is going to give me the answer, and I'm applying a mathematical rule. So now this will have given us 3 times root of 7 times what? 3. All over. This will give us 7 root. Guys, what is 24? 24 will give us 4 times 6. Now, what about 98? 98 would have given us 98 divided by 2 will give us 49. And 49 is a perfect square. Guys, hope you can see. You see now the misery that we have here. Okay, now let's go. So this would have given us 3, 2 root 49 times 3 times 2. So at this point, all we simply need to do here is to now multiply 2 by 3, the numbers outside the bracket, then times root 2 times root 3 times root 7 times this other root 7. This what we just did now, just split it. Root 7, root 2, root 3. Then this 3 and this 2, they are first here. All over 7. Now the square root of 4 is 2. Then times root 6. Then multiply by 2 times the square root of 49 is the same thing as square root of 7 times 7. Then times square root of 2. This is what this means. Root 7 times root 7 times root 2. So now we need to cancel out, guys. Here, all we need to do is these 2. We cancel this. Alright? We are just going to reduce this fraction. Then this 7. We cancel this. Root 7 takes care of this. Gradually, then this root 2, we cancel root 2. Hope you have got what I did now. Then the remaining functions here are 3 times root 3. All over. At the denominator, we have 7 times, the number here is 2 times root 6. This is exactly what we have here. Now the next thing we do is to quickly multiply this. This will have given us 3 root 3 over 14 root 6. Now we cannot leave our answer like this. Get it clear that you don't have square root at the denominator. This is where rationalization of Surds comes in, and that's what we are going to be looking at in our next video. Rationalization of Surds. Now at this point, all I need to do now is to bring this and this into one square root first, and that would have happened, and that will give us something of this nature. 3 over 14 all root 3 over 6. Guys, this is what we have. Now let's continue the solving. Okay, now let's continue the solving here. At this point, guys, what do we do? All we just need to do here is to put down 3 over 14 root 1 over 3. So 1 over 2. This is what we have. Alright? 3 divided 7 is what? 3 divided by 6 divided by 3 is this 2. Now we know, of course, that this would have given us 3 over 14, 1 over root 2. Of course, the square root of 1 is 1, but the square root of 2 is 2. Guys, we cannot leave our answer like this. It is highly prohibited in mathematics that you have your answer, that you leave your answer having a square root at the denominator. You don't do that. So what do? You now rationalize. And how do you rationalize here? I think this was our rule number 5. So rationalize, all you simply do is to multiply both the numerator and the denominator by that root at the denominator. Now this is the root we have at the denominator, root 2. Now multiply both the numerator and the denominator by root 2. When we multiply the numerator now, we are going to have 3 root 2 all over. When we multiply the denominator, guys, get it clear. Root 2 times root 2 is 2. That was one of the theory we had today in theory number 3 or theory number 4. That root A times root A is A. So root 2 times root 2 is 2. And 2 times 14 would have given us 28. This is the answer to this particular question. 3 root 2 over 28. 3 root 2 over 28. This is the answer to this particular question. Now, what next do we do? We move ahead to looking at question number 6. Now, in question number 6, guys, we are simply asked to simplify 6 root 3 times root 128 all over root 200 times 5 root 8. What do we do as usual? We are going to be reducing it. Now, this is already in Italy's short form, right? Now, but this, we can convert this to Italy's short form. We can convert this one to also to Italy's short form. Also, we can do that to 8. Now, then we are going to have this as 6 root 3 times. Now, what are the two factors that will give us 128 in such a way that one of it will be what? A perfect square. That times 2, 64 by 2 is 128, for which 64 is a perfect square. Then all over, and the denominator, what will give us 200? The factor of 200 whereby one will be perfect square is 100 times 2. So we have 100 times 2. Then times 5 root 4 times 2 will give us 8. Because 2 times 8, 2 times 4 is 8, and 4 is a perfect square. Now, guys, what else do we do here? The next thing we are probably going to do here right now is we are going to have this as 6 root 3 times what is root 64? Guys, the root of 64 is 8. Then we are going to have 8 root 2 all over. What's the root of 100, guys? The root of 100 is 10 root 2 times what is the root of 4? Guys, the square root of 4 is 2. And 2 times this 5 here would have given us 10 also. I'm going to have 10 root 2. This is it. So what's the next thing we quickly do here? The next thing we do is to cancel out if there are possible ways we can. Now square root 2 can take care of square root 2. Then also, but we multiply this 8 times 6. Now, otherwise here we are going to now have 8, 6 times 8 times root 3 all over 10 times root 2. So when we multiply this 6 times 8, guys, we are going to have 48. So we have 48 over 10. And of course, since we have a square root at the denominator, all we need to do now is to rationalize. Now this is what we have. 66 times 8 is 48 root 3. And 10 times root 2 is 10 root 2. Now that we have a root at the denominator, we need to rationalize. And to rationalize, what we simply do is to look out for the square root at the denominator. And the square root at the denominator is root of 2. So we are going to multiply both the numerator and the denominator with root 2. We are going to have root 2 over root 2. Now, root 2 times root 3 will give us root 6, because a number inside square root can multiply another number inside square root. So root 2 times root 3 is the same thing as root 3 times 2, both inside the same square root using rule number 1, right? So this will have given us 48 root 6 all over. Now, guys, root 2 times root 2 is going to give us 2, because the root of a number multiplied by the root of the same number would have given us the number, right? And that happens to be, I think, rule number 3, right? Yes. So this would have given us 10 times 2. Then finally, understand that this would have given us 48 root 6 over 20. Now, guys, 48 and 20 have something in common. Now, what do they have in common? They have 2 in common, as well they have 4 in common. So 4 into 48, guys, we are going to have 12. And 4 into 20, we are going to have 5 root 6. This is the answer to this very question. So guys, the next thing we are going to veer into now is complex sort using the rationalization method. Of course, the rationalization method comes in when you have a square root at the denominator or an irrational number at the denominator. Now, that is the next stage we are going into, and we find the link to that very video in the description below. Ensure you make your positive comment and like this video, every of our videos, like them and share our videos, and as well subscribe to this YouTube channel if you have not done so, or if you have subscribed but you have not hit the notification bell. We don't notify you anytime we upload. Please, you can hit the notification bell so that anytime we upload new content, you will be the first person, the very first person to be notified. Love you guys. Thanks for watching. See you in the next video.